So I'm going to give you a quick tour of my off-grid solar setup I'm working on at home. I just started this about 2 or 3 weeks ago, and I've been making incremental upgrades every couple days or so. So this is the state it's in as of now. It's kind of the beginning of April now, and yeah, this is what state it's in now. So basically I've got 400-watt panels on the roof, and then the wires run down here to these charge controllers, and they've got I've got these little cheap charge controllers that came with the panels, and I start off with all 4 panels on these charge controllers they came with. And then just about a week or so ago, I got this bigger maximum power point tracking charge controller, and it's from EP and this specific model is a Tracer 4215BN, if you're curious. But this thing seems to perform better than these other ones. I think soon, maybe even today, I'll just connect all 4 panels to this bigger EP controller, because 4 panels is still well within the amperage that this thing can handle. I mostly left it as it was with these other 2 panels on these 2 old controllers for a little while, because I wanted to see what the difference was. But this one seems to be performing quite a bit better, so I'll probably connect 4 to this thing soon. And then when I connect 4 panels to this one controller, that'll be pretty close to maxing it out. So if I get more than like one more panel, probably I'll have to get a second controller and set it up. And then as I'm doing it, I'm also building this big wooden frame to kind of put everything on. And the bigger EP controller's got this really cool interface where you can see a lot of interesting things. So like on this display, it shows you the voltage and the amperage that the panels are operating at, and then the voltage and amperage that it's feeding to the battery. And then you can also have a load on it, and that's what would show up here. But you can scroll through a couple screens and see things like for the panels, this is how many. This shows you how many watts it's drawing from them, and they're 2 panels each 100 watts. So we're getting 183 watts. So we're pretty close to ideal conditions now. And yeah, there's a lot of interesting stuff you can see, and you can connect this thing up to your computer and get a lot of really cool data off of it that way. But I haven't tried that yet. I've just tried the little controller that you mess with this way. And so going down from there to the batteries. Right now I've just got 2 sealed lead acid batteries, 12 volts, and they're each 80 amp hours. And I got these mostly just because when I went to Batteries Plus to look for batteries, this was kind of the first thing they had that was about the right size for what I was looking for. But lately I've been finding out through research that it sounds a lot like the lithium iron phosphate batteries are kind of the way to go. So I'm treating these as mostly for me to learn on and sort of semi-expendable. So that's, I'm kind of treating these as for educational purposes for me. But right now I'm doing an experiment where I'm charging my Tesla off of this. So I can see with this little clamp meter how many amps it's drawing from along each wire. So the battery that the 2 older controllers are connected to is about 44 amps now, and the new one's about 54. So it seems like every time I've done this experiment where I put a load on the whole thing, it draws more amperage from the one that's got the EP controller, which I don't really understand because they're connected in parallel, and I would expect them to charge up. Even though there's 2 different types of controllers, I would expect them to charge up to the same level, and they're the same battery and the same age, and I would expect them to just have the same amperage from them, but that hasn't been the case so far. So haven't quite figured out yet why that is. And then I can see also how many amps the inverter's drawing. So right now it's just under 100 amps. And this is the inverter I've got, and it's a 3000 watt inverter, and this is probably actually kind of mounted upside down really, because in here from the top there's fans and they suck air in, so it would be a little bit more ideal if it were mounted the other way and it could pull air up and then take advantage of the tendency of hot air to rise. But it probably doesn't matter that much because it's a 3000 watt inverter and I'm drawing maybe like 1200 from it now. So this thing's barely breaking a sweat the way I'm using it right now, and it probably really doesn't matter that much. And so coming off of that, I've just plugged it in my regular wall outlet charger for my Tesla. And I've been doing experiments every couple days where I'll charge it and I'll write down the conditions when I started, the time, how many miles of range I got and stuff like that. So with this setup, plugging it in the middle of the day, I've been able to get 3 miles or so worth of range out of about an hour of charging, which isn't too bad. It's kind of a good starting point. And I'm just gonna incrementally add panels and add batteries and upgrade this. And in the short term, I'm trying to do as much of my car charging as I can off of this. And 3 miles per hour might seem pretty unimpressive, but my commute to work most days is only about 20 miles, so it doesn't take much to be able to cover that. And maybe if I can just do it every other day or every third day, that's fine too. This whole thing's kind of an experiment anyway, so I'm just kind of starting small and then seeing what I can do with it. But yeah, that's it as of right now. I'm probably going to keep making upgrades to this, and then as I make upgrades, I'll probably make videos to show y'all. But that's it. Thanks for watching.